Welcome back. In this clip, we'll talk about the emission of the dust particle from the nParticle 1. Alright, so if I play the timeline, you can see we have the secondary emissions of the debris particles. So let's do one thing. Let's start emitting the dust particles, and let's also hide the small instancer. And now if I play the timeline, you can see there's definitely, a big difference. Right now this is just looking very unnatural kind of a scene because we don't have the debris particles and even we don't have the dust. So let's concentrate upon the dust particles. So for that we can select the nParticle 1. Let's move inside the nParticles menu, and let's say we have emit from object, and make sure that we are using the different nucleus in this case because I would like to use the per point emission rates. And since we have already talked about the per point emission rates, whenever we have to use the per point emission rates, it's always advisable to use a different solver so that it cannot create issues while emitting the particles with respect to the same solver. So I'm going with a different solver, and I'm going with the emitter type as a Omni. We have the rate set to the 50, and with the speed 2.5, random speed 1.0, hit the option create. The moment we create this, we have nucleus 2. Make sure we also enable the ground plane. Alright, and make sure that we have the space scale value that is similar to the nParticle 1, which is I guess 0.25. Okay, and now let's play the timeline. So here we go with the dust particle, but there are some issues. First is that the scene looks totally artificial, as you can see the pattern which it is drawing. And secondly, there is a continuous, you can notice the emission of the particles. So this cannot happen because once the big particle takes the rest, there shouldn't be any emission of the dust particles. Whatsoever the dust has to come or emit, it can emit in the initial in the initial frames or in the initial stage. And most importantly, the overall pattern appears to me quite unnatural and artificial. So we have to fix two things. One is this pattern, and second is the emission of the consistent emission of the dust particle. All right, so let's do one thing to fix the pattern. I can select the nParticle 2, and let me also quickly name this as dust. All right, so dust is fine. Now we can select the dust, and we can move inside the field solver. We can provide the turbulence field. All right, let's position this, reposition this. Let's increase the magnitude to a value of 125. Put a key at frame 1. Get rid of the attenuations. Also adjust the frequency to somewhere around 0.75. Now if we play the timeline, now you see the pattern simply get dissolved. But yes, the particles are way too much fast, so we don't need to worry about this. Let's say at frame 125, we can bring the magnitude back to the 0. Let's move to the graph editor also, and let's also decrease the interpolation types to the linear so that we don't have any ease in or ease out. Alright, now if we play, you can see we don't have that kind of artificial pattern, and now these particles are simply been getting settled on the floor. And now let's also select the dust particles, bring some more changes inside this. Let's reduce the point size to the 1. Let's bring some more changes inside the overall color. Let's say we have this brown color, add another entry list, go with the lighter one, and go with this a little dark one. And I think so the dark is already there, used for the yellow. And finally we can have some white color as well. Now go for the color input type, set to the randomized, increase the slider, and opt for your own color settings. Let's get rid of this yellow. It's quite making the particle looks completely different. Let's increase this brown one. Let's also make this a little more less dark, and that is something which is very nice. Bring this to the down side, and we can obviously adjust the way we want, and that's pretty much fine. Now at least we are done with the repetitive pattern or the artificial pattern, but we are still required to fix the the continuous, you can say, the emission of the particles. If it is little difficult for you to observe, what I can do, I can simply select the dust particle, take you inside that count, and notice that once the particle, the nParticle 1, got itself settled upon the floor, you'll notice that the count for the dust particle keeps on increasing. That is something, bad. So notice the particles are settled, and still we have approximately 19,000 particles at 126 frame. If I increase the timeline and put a stop, you can see we have 25,000 particles, and even if I increase, you can note that the particle count is consistently increasing. So that's the point of concern. The good thing is that we have the solutions. For that, we need to use the per point emission rates, obviously. So we have the emitter 2, which is the emitter for the dust particles. We can select the emitter 2, move inside the nParticle menu, and we have per point emission rates. Alright, click this options. The moment we click this, now in the nParticle 1, we have another great PP attribute, that is the emitter 2 rate per particles. Alright, now let's do one thing. Let's move inside this, and before I just start writing some expressions, if I play the timeline, you'll see no more dust will emit. That's simply because inside the emitter to rate pp, if we are going to create the ramp, which is obviously I'm not going to do, the min and max value is set to the 0. So that's the reason none of the particle is basically getting emitted. And another reason is also that the rate is now no more in charge or responsible for the emission of the dust particles. It's now totally expression based, so we can go inside the creation expressions. Let's say inside the creation mode, we can have nParticle shape 1 dot emitter to rate pp that equals to, let's say, 150, and that's just for the creation frames. And now if we play the timeline, you'll see everything now comes back. That's pretty nice. Alright, but still we are required to put a stop upon the particles. The particles are consistently, they are being getting emitted. So there's a very nice and clean way to put a stop on them. If we just multiply the emitter to rate pp with respect to the speed of the nParticle 1. So the moment the speed of the nParticle 1 takes the value of 0, obviously the rate of emission becomes a 0. Quite straightforward and quite logical. So bring this over here, and let's say we can have this equals to the speed, and let's do one thing. Let's use simple speed only, and then we'll decide how much we have to multiply. Right now the particle is very small, but the good thing is that, guys, there is no more emission. Let me take you inside the dust. Inside the count attribute, it is 3785. Now if we increase the timeline, you can see there is no increment of the particle. So that means we are now successful in putting a stop to the dust particle. But the emission is way too much small. We can fix this, not a problem. Simply go inside the runtime before dynamics and simply multiply this with a value of, let's say, 10. So that means if we are multiplying this figure with the 10, we should have somewhere around 25 to 35,000 particles. And if in case you want to emit some more particles, you can definitely emit them, not a problem. So with this, we have quite dusty and quite a messy kind of a destructions. Let's also bring the instancer 2 to get more better look and feel. And if you want to render this with respect to the Mendeley, you can simply do this. For that, I recommend you to move inside the shading sections of the dust particles, and let's say you can change the type from points to the tube. The moment you click this, you can see there's a lot of mess going on. Definitely we can bring down the radius to, let's say, 0.010, and to the radius to, let's say, 0.010. Now we don't require to use the tail size. If we put a value of 0, then they will just act as a point particles, but yes, they are the SW, which means they are software rendered particles. If in case you think so the radius is way too much small, you can definitely increase this. I recommend if we go with the value of 0.020 or maybe 0.0, let's say 20 should be fine. You can use a little tail size as well, not a problem. Maximum 0.5. But notice, once you play the timeline, you'll see the particle will automatically going to catch up with the tail size, because we all know that the fundamentals of the streak and the tube are pretty much similar. These particles are velocity dependent. The tail size will get adjust automatically based upon the velocity. So in the initial frames we have higher velocity, so if we don't want things like this, we can simply make the tail size to a value of 0. So with that, now they are kind of a point particles, but they are software render particles. Alright, if in case you wish to increase the tail size radius 2, or I'm sorry, the radius 1, you can increase the values. Alright, depends totally upon your artistic decisions. You can also bring the opacity value to little less as well. Alright, I'm sorry, 1 is quite fine. Now with this, we are good to go with our effect. We have tube particles as well. You can comfortably render them with the mental ray, because I don't think so that Arnold can handle the tube type of particles. So for this effect, mental ray is a good choice. And now we are done with this. We can save the file, and let me show you with the play blast what I have. This is the play blast we have, and here we go. I guess this is still a WIP, work in progress. If someone wish to add more particles, if you are required to add some more sense of believability, or you want to push this thing to the further level, I think you can add a fourth particle system. That's totally up to you, because the good thing regarding this effect is that we have customized attributes, we have our own MEL expressions and functions. So this particular kind of effect is completely customized effect. You can revisit the settings anytime you want. Everything is so much flexible and everything is under your control. That's the power of expressions we have. Alright, so with this we have successfully completed our module. Now it's time to take a look inside the summary of our module. Alright, let's take a quick look inside the summary of our module. So we talk about the nParticle instancer, with the help of which we can create customized geometries, and then we use the shader to create the polygon debris. Then we talk about the controlling scale, spin and speed attributes of our particle instancer, followed by the bounce scale pp, and then we have the secondary debris with the help of the emit command. Then we talk about the simulation of the dust particles. Alright, and finally we have the per point emission rates to control the emission and stop of the dust particles. Alright, so with this our module is now complete, and now let's move to the next module where we talk about the effect of a dry sand using nParticles and constraints.